Today we shall be discussing on centrifugation. It is the most widely used technique which is used in molecular biology, second is it is also used in biochemistry, and thirdly it is used in medical field. Next, what is the instrument related to centrifugation? It is centrifuge. Centrifuge is a device which separates the molecules on the basis of shape, size, density, then you have viscosity, and then rotor speed. How do it separate on the basis of shape? How do it separate on the basis of size? How do it separate on the basis of density? It depends upon the rate of density or rate of size. Next, which molecules are separated on the basis of centrifugation? The molecules separated are proteins, cell organelles, then you have nucleic acids, which are separated on the basis of centrifugation. The main which is involved in centrifugation is density. You have solvent and particles whose density is higher they will naturally sink at the bottom, and whose density is lower they will come up, so you can separate on the basis of density. Next it comes the principle of centrifugation. Principle of centrifugation, two of the forces are there. First is centrifugal and other one is centripetal force. Centrifugal force is the outward force and centripetal force is the inward force. Centrifugal force F is equal to mr omega square. M is the mass of particle, r is the radius, and omega is the angular velocity. Next comes angular velocity. That is omega is equal to 2 pi by 60 revolution per minute, or you can write it as 2 pi by 60 rpm. After angular velocity it comes centrifugal field. That is denoted by G. G is equal to r omega square, and you already know that Omega is equal to 2 pi by 60 rpm. You have to substitute the value of omega here. It comes to be r into 2 pi by 60. When you will further solve it, it will come r into 4 pi square to rpm square. After that it comes relative centrifugal field. That is Rc is equal to Fc upon Fg, that is equal to Mr omega square upon Mg, where you will cancel M, it comes out to be R omega square upon G. Then further when we write it, R into 2, it was 4 pi square upon 3600 into rpm square upon G. After taking the value of G as 981 centimeter per second square, it comes out to be 1.12 into rpm square into R. So you just put the value of 1.12 and you can put rpm and then radius, you can get the RCF. Then after that it comes sedimentation coefficient. It comes to be S is equal to V upon R omega square, and its unit is Swedberg, and 1 Swedberg, that is denoted by S, it will be equal to 10 to the power minus 13 seconds. Then in centrifugation, after that it comes to rotors. And rotors, they depend upon the centrifuge you are using. Rotors are basically made up of titanium because they are corrosion resistant. Then you have different types of rotor, basically fixed angle. And second you have swinging bucket. As the name itself indicates that if fixed angle is there, that means it is not moving, and swinging bucket is, as you are using bucket and swinging it like that, the condition is same in swinging bucket rotor. This is fixed angle in which you have to less distance will be travelled, and it is easy to separate, and this is most commonly used. Then you have swinging bucket. It is going to swing like a bucket. The result of swinging bucket rotor is very specific in comparative to fixed angle, but this is easy to use. So we use swinging bucket only in case of nucleic acids. Then in usually labs we use different type of centrifuge, we also call it compifuge. Then we use their small one and you have large one. You might all be familiar with, you might have, all of you have seen that which one is a small one and which one is larger one. But there is a difference in a small one and larger one. The difference is that you cannot set the temperature. In a small one you have to do at room temperature, but in large centrifuge you can just decrease the temperature. You can use up to 4 degrees Celsius. And we will discuss different types of centrifuge and different types of centrifugation in second class.